Hello students, कैसे हो आप सब? So in today's session motion and play, lecture 3. So let us understand what are vectors. So officially we will start vectors today. What is vector? What are the types of vector? In today's session we will understand that, right? So let us begin. First of all, we have to understand that any physical quantities, right? Physical quantities are divided into two categories. The one which has only magnitude, right? Example, mass. Mass, 5 kg, 10 kg, 50 kg, whatever you are saying. So if you require to say only the magnitude, there is no need of specific mention of the direction, right? So those those quantities which have only magnitude are called scalars, right? Example of scalars are mass, time, work, power. When you say time, time is what? You say, okay, 10 seconds, 1 hour, 10 hours, whatever you were saying, 10 hours or so. So you are only mentioning the magnitude. You are not required to mention the direction. You are aware of this thing, very simple, it is very simple to note here that time flows in, a general direction. What is that direction? Fixed direction. There is no need to mention the direction of flow of time, right? This is from past to present to future. So that is how time like flies or spent, time goes. So this we need to understand, that if you require to mention specifically the direction also, then it is going to be a vector. We'll talk about that vector. First of all, scalar. We have understood that, okay, mass, time, work, these quantities do not require any special mention of the direction. Only magnitude will be sufficient enough to express that, right? Okay. When you measure these quantities, you require to mention only magnitude. Now, there are another category of quantities called vectors. In vectors, we need to specifically mention the direction. I tell you why. Suppose you are staying at your home right now. From your home, if I would tell you that my home is 15 kilometers, right? 15 kilometers. Would you be able to find out my location if you would only mention that magnitude, like 15 kilometers, right? You would not be able to do, because I did not tell you 15 kilometers in this particular direction. We need to mention specifically in what direction, right? It's not only the magnitude that would matter, we need to specifically mention the direction, right? Airplane is flowing, right? Airplane is moving, and it is moving in a particular direction. You would say northeast, southwest. In that particular fashion, you need to mention, okay, it is moving from one point to another in this particular direction. So when you are required to describe the displacement of a particle or a body or a person or whatever, you are required to specifically mention the direction, not only the magnitude. If you would only say the magnitude, the exact description would not be possible, right? So that is why what you need to do is you need to specifically mention the direction. Okay, few more things are also there. we need to understand that. We will talk about this. One thing is, in addition to magnitude, you need direction also. So those quantities which requires what? Direction, to specifically mention it, specifically mention the direction. So those quantities are called vectors. So displacement, velocity, acceleration, force, field, these are vectors. All right. Now, we need to define vectors in broader terms. Why? I give you an example. There are few quantities which have the sense of magnitude. In addition to the magnitude, it has a sense of direction. But still, that quantity is not a vector because it lacks one more category, one more characteristics, right? It lacks one more characteristics. And what is that characteristics? These quantities, we call vectors. Vectors should be added with a particular law, following particular law of parallelogram of addition, and that is required. We will talk about that. There is an example of angular displacement. Small angular displacement can be considered as vector. Large angular displacement will not be a vector because large angular displacement do not follow the commutative law, right? So let us talk about this commutative law also. Those quantities which have two things, magnitude and specific direction. Along with this two, they must follow these two laws, right? They must follow these two laws. First law is parallelogram law of addition. Second law is commutative law. So as I told you, large angular displacement is not a vector since it does not follow. It doesn't follow commutative law. Right? So this we need to understand. Small angular displacement is a vector because that follows commutative law. What is commutative law? That is important here to note, is that it is very simple. You are saying vector A and vector B. So commutative law says vector A plus B equals vector A plus B equals B plus A. Okay. This is commutative law. Parallelogram law, we will talk about this. Parallelogram law of addition, we'll talk about this when we will be doing vector addition. Okay? Right now, this one thing to describe, to understand that why these parameters are required. Right? These characteristics of a vector should be there. Along with magnitude, it must have direction. Right? And that vector must follow these two laws as well. Here, why this parallelogram law of addition is required? I tell you, I give you an example. Suppose you are adding 4 plus 3. Algebraically, if you would add, you would always get 7. But with the help of this law, we would come to know that 4 plus 3 can be 1 also. 4 plus 3 can be 5 also. 4 plus 3 can be 7 also. This is the beauty of this particular law. Let us understand how this is going to be. Okay, so if this is 4, this is 3, you are adding this. If these two are inclined in this manner, it's 1. And if these two are inclined in this, let's say This is 3 here, this is 3, and this is 4. If you will add in this manner, what you will get? What you will get? You will get, if theta is here, theta is 90 degree between these two. If here theta is 180 degree, then it is going to be 4 square plus 3 square. This is the resultant. Okay, this is vector, let's say this is vector A, this is vector B. So here in this case, A plus B magnitude would be this. Obviously it is 5. Right, here in this, A plus B, if you are adding this, would be what? It would be 4 minus 3, that is 1. Right? If you are saying, okay, this is 4 and this is 4 and this is 3. When A and B are along the same direction, when theta is 0, then A plus B vector mod of this would be 4 plus 3, that is 7. So what did you observe? Here, while adding the two vectors, we need to take into account how the two vectors are inclined with each other. Inclined to each other, right? Here, they are making 0 degree. The two vectors are making 0 degree. Here they are making 90 degree. Here they are making 180 degree with each other. That's why results are different. So parallelogram law of addition says simple thing. A square plus B square plus 2AB cos theta. In detail we will talk about this. Just to mention this thing, why these characteristics of a vector should be there. Okay, that actually we are discussing. We will do this derivation and all other stuff in detail about this parallelogram law, right, when we will be doing vector addition. So right now we just understand, just to relate that how this is going to differentiate this with the with the addition of scalars. Okay, this is there. You are saying, okay, vector 1 is there, vector A is there, vector A has got some direction, vector B has got some direction. When you are adding them together, what would happen? They would be, inclined to some angle with one another, right? And in the different scenarios, you found that the results are different. Here you see that it is 7 also, 4 plus 3. One vector has got 4 unit, another vector has got 3 unit. When you are adding them together, it may be at it may be 7, it may be 5 units, it may be 1 unit, depending upon how the two vectors are inclined, right? So this is interesting fact about this vector. Okay, now let us move further. We will talk about the type of vectors. Okay, so broadly, if we divide the vectors, it is in vectors. They are in 2 categories, right? Category 1, polar vectors. Category 2, axial vectors. Right? What are polar vectors? Polar vectors have starting point or point of application are called polar vectors. So all the parameters which has got linear sense, like you were saying linear velocity, linear displacement, right? You were saying force. When you say force is a vector, fine. Why force is a polar vector? Because force you are applying at a certain point, right? When you say displacement vector has some starting point, right? Displacement vector has some starting point. Force has got some point of application. So that is why force and linear displacements are polar vectors. All such vectors which has got linear sense. You were saying, okay, linearly this is there. It has got point of application. Like suppose you are saying that here you are applying force. This is point of application of force. Or suppose you are saying from this origin there is a displacement in this direction. So this is initial point. Displacement is in this direction. You are saying this is initial point. So vectors which have got two things, any of the two or both, right? What? Starting point or point of application, right? Those two vectors are called polar vectors. Now, another category, axial vectors. What are axial vectors? Those vectors have got sense of, they represent what? Circular. They represent rotational effect, circular or rotational effect, and act along the axis of rotation in accordance with right hand screw rule. I give you an example. You must have seen on the electric board that there are screws, right? So those screws are right hand screw. If you turn those screws along clockwise, it gets into the wall. If you turn the screw anti-clockwise, it comes out of the wall. Notice this thing. So here we need to understand that, okay, this is the sense of direction these vectors are associated with. Right hand screw rule. Okay. So these vectors, all those vectors which have got rotational effect and act along the axis are called axial vectors. And axial vectors have the direction determined as per what? As per right hand screw rule or right hand thumb rule. That we need to understand. Right hand screw rule, you can visualize that on the wall. If you are interested in inserting into the wall, the screw you want to insert into the wall, what you will do? You will turn the screw clockwise. If you are turning the screw anti-clockwise, it will come out of the wall, right? So this is very important here. Okay. So these are axial vectors. All vectors which have got this rotational effect, like angular velocity, angular momentum, torque, and there are many other vectors which have got angular displacement, angular velocity, angular momentum, angular acceleration, torque, right? These things, all angular stuff would fall into this category. Okay, now move on. Few another type of vectors. These are simple. Unit vectors. When you say unit vectors, this is important because you would be given a vector and you would require to find out the unit vector of that. You would be given a vector and you would be required to find out the unit vector. So first of all, understand what is unit vector. Unit vector is nothing but this. Magnitude of this unit vector will be same as that of the vector itself, right? And the direction, you are saying will be the same as that of the given vectors. Example, I tell you, suppose you wish to find out the unit vector of vector A. Unit vector of vector A. In the last two sessions, we talked about how velocity, displacement or position vectors are represented in a plane. So we will, right now we will focus in that plane, x and y plane. So unit vector directed along x-axis will be I cap and j cap. So A has got two components, one along x-axis, one along y-axis. I have suppose 2i plus 3j cap. So what do we mean by this? It has got its effect along x-axis equal to 2 units, y-axis equal to 3 units. I and j are called unit vectors along x-axis and y-axis. I'm writing it here again. I'm writing it here again. I cap, we call it I cap. I cap and J cap are the unit vectors, are the direction vectors along x-axis. Direction vectors, right? Direction vectors or unit vectors representing x-axis, and y-axis respectively, right? So vector A would be, unit vector of vector A would be represented by this. A cap equals vector divided by its magnitude. Vector divided by its magnitude. This is unit vector. Okay. How this magnitude is taken? This. Just use the I and J are inclined at 90 degree, I and J. If you will use the Pythagoras theorem, you will be able to get it. So you need to simply do this thing. 2 square plus 3 square. Just this thing will give you the magnitude of this vector, right? And then, yes, you will have this unit vector. Okay. And another vector is called, equal vector. Two vectors are said to be equal when they have got equal magnitude and they are inclined along same direction. They have same direction, right? So here we need to understand magnitude as well as direction. If both are equal, then the two vectors are called equal vectors. Okay, we will move further in the next session. There are few more vectors. We will talk about that, and then we will do questions based on these things, these topics, like find out this unit vector, how to find out magnitude, and all other stuff in the next session. The basic types of vectors, and then few numericals also we will be doing. Okay, this is the